Hello and welcome to today's session in our journey through the world of AI. In the last few units, we learned about supervised learning, which is characterized by having a lot of labeled data to learn from. But what if we have a lot of data without any labels? Today we will learn how so-called unsupervised learning works with such data. Once more, we want to start with a game. We want to get rich by searching and finding a lot of gold in the Wild West. We have a lot of data in the sense of reports of gold findings and can operate 3 excavation teams, symbolized by a coin. We want to position our excavation teams as best as possible inside a gold field, and therefore within a group of reported gold findings, just as in the example on the slide. The best spot for the excavation team is right in the middle of a gold field. So here I have the reported gold findings with the respective X and Y coordinates and a map of the Wild West. The rules are that I can only have a look at one of those gold findings at a time, and the only further resource I have are those coins representing our excavation teams. After all reported findings are processed, we will have our final excavation locations and start to dig. So I already drew the first gold finding. It was at x 9 and y equals 8. Let's remember this location by putting one of our coins here. Okay, now let's go for the second card. We have x 23 and y 12. Alright, I can once more put a coin on this spot. The same goes for the third reported gold find. But what now? If you want to figure out your own way to do this, you can pause the video and follow the link in the video description, where you can test your own ideas. As for me, I will just take the closest team and move it a bit in the direction of the new location. So for example, and I will proceed to do this for the next location. Okay, now things get interesting. Did we position our excavation teams well? Alright, 2 teams are pretty much perfectly in a gold field, while 1 team is a bit too far up. Let's recap our game. We had a lot of data in the form of reported gold findings. We processed one such location after the other by identifying the closest excavation team and moving it about half of the distance in the new location's direction. This way, our algorithm finds the groups of gold findings. What we essentially did is develop an unsupervised learning procedure.
As input, we had a lot of unlabeled data. We simply had a lot of gold findings and the respective x and y coordinates. as data points, without any information whether this would be a good point to dig or not. In the same way, our robot has a lot of geometrical shapes as input data, without any labels such as A, B, or C, as we had with supervised learning. The robot now compares the data and tries to find similarities and patterns within the input data. He found shapes with similar attributes, in our case a similar number of corners. The same way, we found similar data in our gold rush scenario. We identified gold findings with similar x and y coordinates. Based on those similarities and patterns in the data, we can now identify clusters and find exceptions. Our robot can identify clusters in its input data, such as shapes with 3 corners, and can also identify outliers or exceptions, such as the circle. For our gold rush, we were able to find clusters of gold findings. With the excavation teams, we furthermore had one prototype for each of those clusters. This is kind of how a typical member of the corresponding cluster looks like. So, in summary, for unsupervised learning, we have input data and we want to derive some structure from it, just by looking at the relationship between the different inputs themselves. We cannot specify which clusters we want to find, and we cannot give feedback whether the model trained is good or not. And that's why we call it unsupervised learning.
Approaches belonging to unsupervised learning are similar to those in statistics, and supervised learning methods are actually applied in statistics. While in reality we might not look for gold sources, we could utilize these approaches to find other clusters, for example in customer data. Our data is now customers in our online shop. Instead of x and y coordinates, we have the average purchases value and the number of purchases for each customer. As we see for this small dataset, we have 2 clusters in our data. If we as humans analyze those 2 clusters in detail, we might characterize those as, on the one hand, customers with a low number of expensive purchases, and on the other hand, we have customers with a lot of fairly cheap purchases. Well, how could we use this information about these 2 clusters now as shop owners? We could tailor our ads and sales to their individual needs. For the first cluster, we could offer a discount for a purchase over a certain limit. For the other cluster, we might offer a 2-for-1 discount. The goal of cluster analysis in marketing is to accurately segment customers in order to achieve more effective customer marketing using personalization. Most of the time, we have a lot more data for each customer than the number of and average price of their purchases. We might have their age, if they use our company credit card, even their income, and so on. It is not as easy to visualize how similar 2 of those customer profiles are, but the idea is the same. In the same way as 2 gold finds might be close together, 2 customer profiles might be similar to each other, just with 5 dimensions instead of 2. And in those 5 dimensions we have in our example, it's extremely difficult, if not impossible, for humans to spot those clusters in tens of thousands of customers. But unsupervised learning enables us to find those clusters with exactly the algorithm we came up with for our gold rush problem. We, as humans, can then analyze those clusters, for example their prototypes, and define which ads, products, and so on the customer will see. We can even utilize these unsupervised approaches to find clusters in news articles or other text documents. An approach that does exactly that is called topic modeling. Let's have a look at this text. We as humans can identify that the topic of this news article seems to be sports. But how can a computer do this? Well, once more, the computer compares the data, which is in this case made up of the different text documents, and tries to find similarities. The text documents are defined by the contained words. Some words are more relevant than others to compare the topics. Therefore, most of the time we exclude words such as the, a, and so on. The more similar the vocabulary used, the more similar the text documents are. If we already compared a lot of text documents, we have already associated certain vocabulary with a certain topic. Words such as champion, league, and stadium are common in certain types of documents. We might call them the yellow topic for the moment, while words such as injury are often present in documents from another topic, and so on. For each of these words, we can compute a certain numeric value that is expressing how strong the connection between this word and a topic is. In the end, the unsupervised learning algorithm assigns a topic to a text, based on the overall frequency of occurrence of certain words. In our example, this text would be part of the yellow topic. We as humans can now conclude that texts from the yellow cluster are probably about sports, while texts from the red cluster have diseases as topic, and so on. This is in contrast to supervised learning, where the computer would make the assignment to a given label, such as sports. We can also use unsupervised learning techniques to, for example, fight fraud through anomaly detection. Instead of focusing on the clusters or common vocabulary, we focus on the outliers. If a customer's credit card purchase differs from the typical patterns, for example, a much higher amount for a different country at a different time of the day than usual, this can be detected, and the respective fraud protection protocols come into action. So today we learned about our final approach to machine learning, unsupervised learning. In contrast to supervised learning, we have unlabeled data, which is analyzed for similarities and patterns, such as the x and y coordinates in our gold rush scenario, customer data, such as the number of and average price of purchases, or the vocabulary of text documents. Those similarities enable the algorithm to identify clusters within the data or find exceptions, which then provide valuable information for us humans. With this, we can identify gold fields, tailor ads to customers, or learn about the topic of a given text without even reading it. Tomorrow, we will once more implement our algorithm in Snap, and in conclusion of this week, reflect on the 3 different paradigms of machine learning we've used. Goodbye.